Florida, where America's rich come for the endless sunshine. 13 years ago, they were joined by an industrial chemist who had built a distinguished career with the American chemicals giant Dow.
When I moved from California, I brought all of my laboratory with me. I bought my building and moved everything and set it up permanently so that I could do independent research on the hydrogen energy. I'd made enough money to retire, and I felt that the Silicon Valley was getting too crowded, and I wanted to move to Florida for the water.
I'm trying to hold back the excitement because I don't want to lose my objectivity. But it is exciting to know where this may take us because it'll be a whole new area of theory. There's things we don't understand because there's something unique about it.
When I was in school, we had to learn glass blowing and we had to learn welding because we had to make our own equipment. A typical scientist would, if they can't buy it out of a catalog, they won't use it, or they can't use it. I think there's some scientists that just will not go to the bench and try to verify or disprove what is proposed. They're too bullheaded to change.
But Dennis Cravens is a scientist who was prepared to advise on the problems of accurate measurement.
I was basically skeptical before I saw the device. This area has been known of false claims, and when I first came to Patterson's lab, it was not exactly the state-of-the-art measurements. The electric meters only had a few digits to it, so there was some question of whether or not they were measuring what we thought they were measuring.
I was finding an increased yield of energy. However, it was so low that it was questionable, and it could be my equipment, my instruments that were actually giving me this increased energy output instead of a true reaction.
With figures so low and so hard to verify, Patterson had actually abandoned his research for over 6 years.
There was a lot of controversy about 1989 in alternative energies, and I went back and decided to take a look at my findings that I'd previously discovered. I have a continuous record of scientific development since 1949. When I went back to my records with a fresh eye, I found that I was producing excess energy, but at a very low level.
Working on a small scale, Patterson set to work to see if he could improve the performance of the heat-generating cell he'd recorded in his notebooks 6 years earlier. His key component is the catalyst, in the form of hundreds of tiny beads.
The most crucial element is the thin metal-coated beads, made up of nickel, palladium, nickel.
Patterson holds the patent for the unique structure of the beads. Microscopic corrugations in the surface provide the largest possible reactive area. There are 1,300 of these beads in the prototype cell. Like so many inventors, Patterson works entirely by trial and error. He modifies one variable after another to achieve better results. But he's not entirely sure which aspects of the design have the greatest effects. The beads are packed into a narrow cylinder, and the electrolyte, distilled water plus 1% lithium sulfate, is pumped into the chamber, while a low voltage is pulsed across the metal beads. As oxygen and hydrogen are given off, a reaction that's not visible to the naked eye seems to take place on or near the surface of the beads. It produces totally unexpected amounts of heat. Their calculations indicate that the cell is producing many times the energy it consumes. No one can yet explain this anomaly.
Well, the interesting thing about the Patterson device is it involves water, but it doesn't split the water in the same way that Stanley Mayer's device does. It simply uses it as a medium, and it generates a lot of excess heat. In his case, a lot of excess heat. The figures he's now quoting are really very, very high indeed. Exactly what is going on isn't clear, but recently they've begun pulsing the water medium inside the device, and this is why they're getting much better results. And throughout a lot of these devices, you have this high pulse voltage as a kind of theme running through it.
The Patterson cell has had several public demonstrations. There is, of course, a very considerable controversy over the figures. At present, the only thing that all scientists agree on is that there isn't a current scientific theory that explains the extraordinary amount of excess energy.
We wanted a more conservative interpretation of the numbers, the most conservative we could, and see if there's still something there. Before, we were seeing measurements of just 30% more heat out than electrical energy in. After we improved it and tightened up things, we have gotten tens of times out as in.
This is an area of physics that especially seems to draw amateurs to, and or low-tech labs, and so therefore they don't have a lot of money to spend on the apparatus. But the first things put together by some maverick in his garage are probably going to be pretty low-tech and pretty crude. But that's okay. I mean, the first observations of radioactivity or whatever were really quite crude. Actually, if you look at the history of invention, most often breakthroughs were found by mavericks working outside their field.
But however innovative they are, the inventors don't have either the knowledge or the resources to validate their results. That's the role that science is best equipped to fill. But an essential problem is how to get the scientific community involved in an area that challenges the received wisdom and which poses a real threat to reputations.
Most of the inventors of this kind of device cannot get their devices to work in a reproducible way, largely because they don't know how they operate. So each time they run their device, it produces different figures. They're all, in many cases, well over unity, and so they're pretty crazy anyway. And scientists coming along and looking at them will say, oh dear, this is a device, it's different every time it runs, there's no control over it. You can't do some work on this. And this is a shame, because scientists should be curious.